Have you ever thought that the security we trust today might only seem secure because so far the right tool to break it hasn't been built? Quantum Safe starts exactly from this point, not as a simple update, but as a new approach to preventing hacking in a world where the rules are about to change. The question that turns everything upside down is, if tomorrow a computer is built that can break today's encryption in a few seconds, what happens? Hacking, encryption, and the hidden weak point. Almost all of today's digital security is built on encryption, from the messages we send in messaging apps to banking transactions, servers, emails, and even blockchain. Most of these systems rely on algorithms whose security is defined by the difficulty of mathematical computations. What does that mean? It means breaking the encryption is possible. But with current computers, it takes so much time that it practically seems impossible. For example, factoring very large numbers or solving complex logarithmic problems. These are the main pillars of modern encryption, but this security rests on one key assumption: that computers will always remain this limited. And this is where quantum computers enter the picture. Quantum computers work with qubits instead of bits, and they can examine multiple states at the same time. As a result, some algorithms that are impractical for classical computers become solvable problems for quantum systems. Algorithms like Shor's have shown that a large part of today's encryption is, at least theoretically, breakable. Even if these computers aren't publicly available yet, the data being stored today could be decrypted in the future. This means today's security may become tomorrow's debt. What is quantum safe and why does it matter? Quantum safe, or post-quantum cryptography, refers to a set of cryptographic methods that remain secure even against attacks from quantum computers. The core idea is simple, but the implementation is complex. Designing algorithms that are not only unbreakable for today's computers, but for quantum ones as well. Contrary to popular belief, quantum safe does not mean using a quantum computer. Rather, it means encryption that runs on conventional systems while assuming the attacker has access to quantum capabilities. These algorithms are typically based on problems that remain unsolvable even with quantum power, or whose cost of being broken is irrationally high, such as lattice-based cryptography, hash-based signatures, code-based algorithms. Right now, organizations like NIST are selecting and finalizing official quantum safe standards. This means the topic is no longer theoretical or experimental. It has entered the implementation phase. Banks, governments, major tech companies, and even blockchain projects are already thinking about migration. Because when quantum arrives, there won't be time to react. Quantum safe isn't just a new technology, it's a shift in mindset about security. Instead of reacting after a crisis, it's about preparing in advance for something that hasn't fully arrived yet. And maybe the real question isn't, can quantum break encryption? But rather this: when that day comes, which systems were ready beforehand and which weren't?